Alright, so here's the new example problem from the arc length lesson. So we need to find the length of the circle x square plus y square equal to 9 in the first quadrant. That means we have a circle, but you only care about what happens in the first quadrant. Okay, so that means the positive x-axis and the positive y-axis. So that means this part. You want to find the length of the curve of that part of the circle. So here's 0, so circle should be touching here 3, because when y is equal to 0, x square is equal to 9, so that means x is either plus 3 or negative 3. But since we are dealing with positive x values here in the first quadrant, here what's touching here is 3, so the radius is 3, so here it should be also 3. Okay, now you want the length of this circle in that first quadrant. Now we have the equation x square plus y square equal to 9. So now you have the option to set this up either in terms of x or in terms of y. It doesn't matter. Okay, you're gonna get the same answer. I'm gonna show you both and pick one to solve the problem. So if you want to set up the integral in terms of x, you need to make y subject. Okay, so I'm going to divide and do that here. So if you want to make y subject, I'm going to kick x square to the right. So y square is 9 minus x square. So y is square root 9 minus x square. Right? We don't need to worry about plus or minus square root because we are working with the positive y values. If you want to set up the integral in terms of y, x should be the subject. So x square equal to 9 minus y square. So x is equal to square root 9 minus y square. Now let's set up the integral, but we need to find the derivative. So here dy dx. So this is same as 9 minus x square to the half. So this is a composite function, a function inside another function. So first you take the derivative of the inside function. So if you differentiate 9 minus x square, you're gonna get minus 2x. Times, if you differentiate parentheses to the half, so it's just you take half out, 9 minus x square, subtract 1 from half. So this is 2 cancel out, minus x times 9 minus x square, half minus 1 is negative 1. So this is minus x, I can bring negative half power to down to make it positive, so it's 9 minus x square to the positive half. So this is dy dx. Now dx dy, so it's the same thing, right? It's just the variable if is different. So you can write this as 9 minus y square to the half. So see, same thing. So if you differentiate, you should get the same thing, but instead of x, you should have y, right? Minus y over 9 minus y square to the half, right? Okay, so now you can set up the integral. So here, if you're setting up the integral for x, right, you're going from x value 0 to 3. So it's square root 1 plus square of this term. So if you square minus x, it's x square. If you square 9 minus x square to the half, half square 2 cancels out. So you get 9 minus x square. So this is the integral that will give you the arc length, and it's represented using x. But if you're going for the y1, y values are also going from 0 to 3. Square root 1 plus. So if you square minus y, it's y square. If you square 9 minus y square to the half power to the square, 2 cancel out. So it's 9 minus y square dy. So it's the same thing, it's just the variable is different. Now I'm going to pick this one to integrate, okay? Because yeah, x is much more familiar than y, doesn't matter, right? So I'm going to integrate 0 to 3, from here 0 to 3, the function 1 square root 1 plus x square over 9 minus x square. So to integrate this, I want to add these two. So I'm going to make the common denominator by multiplying 1 by 9 minus x square and dividing by 9 minus x square. So we have common denominator. So now we have a common denominator where the denominator is 9 minus x square, numerator is 9 minus x square plus x square. So x square cancels out. So what we get is square root 9 over 9 minus x square. So now we can take the square root of numerator and denominator separately. Square root of 9 is 3. Square root of 9 minus x square, well, we'll keep it like this. Now to solve this integral, if you remember, we have to use trigonometric substitution. Okay, so my substitute here is, since it's 9 minus x square format, constant minus x square format, it's going to be sine. And the substitute is, if you remember trigonometric substitution, it's x is equal to 3 sine theta. Okay, so if x is equal to 3 sine theta, okay, we have to change the limits. So what happens if x is equal to 1? What is theta? So if x is equal to 0, so if x is equal to 3 sine theta, so sine theta equal to 0. So you want to find theta that give you the sine value of theta 0. So that's theta 0, right? If theta is 0, sine 0 is 0. So when x is equal to 0, theta is 0. And when x is equal to 3, I want to find what is theta. So 3 is equal to 3 sine theta. So if you plug it to the substitute, so 3 cancel out, sine theta is 1. When do you get sine theta 1? For which theta values? When theta is pi over 2. So you're going from 0 to pi over 2. So you need to change the limits, okay? So 3 over square root 9 minus x square is square of 3 sine theta. And dx, well, dx d theta, if you differentiate 3 sine theta, you're going to get 3 cosine theta. So dx is 3 cosine theta d theta. So we have 0 to pi over 2, 3 over square root 9 minus, so here it's 3 cosine theta d theta. That's your dx. Now I can square this. So if you square 3, it's 9. If you square sine, it's sine square theta. 3 cosine theta d theta. So this we get 0 to pi over 3, 3 over, I can factor 9 out. So it's 1 minus sine square theta, 3 cosine theta d theta. Now 3 over, now 1 minus sine square theta is same as cosine square theta from the Pythagorean identity. So now we can take the square root. So it's square root of 9 is 3, square root of cosine square theta is cosine theta. So this is what we get. 3 cosine theta cancels out. So it's just we need to integrate 3 with respect to theta. So we can take 3 out of the integral. Okay, this should be pi over 2. And we are just integrating 1, right? So if you integrate 1, you're going to get theta, right? So we get 3 theta going from 0 to pi over 2. So now let's plug pi over 2. So it's 3 pi over 2 minus, if you plug 0, it's 0. So 3 pi over 2. That's the length of that circle in the first quadrant. Okay, right. So yeah, so this problem is a little bit involved because we had to use trigonometric substitution to integrate it, and also we had to use chain rule to differentiate it. And also we can set up this integral in terms of x, so in terms of y. I showed you the both ways. So I solved the first one. If you solve the second one, you should still get the 3 pi over 2. Okay, right. So that's a different example. Okay, all right. I'll see you in a new video.